Welcome everybody. This is the njmon or nmon or nmon user meeting. Okay, so this is the second one of these. Just a little reminder in here. We're talking about gathering performance stats on AIX and the virtual I/O server, which is AIX under the covers. Virtual I/O server. The virtual I/O server has a lot more stats that it can gather about the virtual disks and virtual networks. And we can do Linux, that's Linux on Power or on AMD64. I always express it that way because it winds up the Intel guys, although they're having a really hard time of it at the moment. Anyway, you got the Z, that's the mainframe, guys, and we run on ARMs on the ARM processor if you're running something like a Raspberry Pi, that sort of thing. We don't do IBM or I for business as we have in here. These guys have all their performance stats in an SQL database inside the operating system. So I don't know how to get those out. That's what we're not covering at the moment. I wish I had a IBM I developer expert I could call on. Perhaps we could add those in as well. This is that's the starter chart if you're completely new to this. So this will be in the deck. So we're talking about a collector on our endpoints, pushing the data into InfluxDB, which is a time series database, and we're using Grafana to draw us lots of pretty graphs. The nice thing about Grafana is you can make up your own graph based on the stats in the database very, very quickly. So although we have a bunch of dashboards to get you started, you can do what you like and have what color you like and what size you like and line graphs or LED running up down. There's a donut chart there and a rev counter like a Porsche or something over in the corner. And we've also made sure that we can get all this data from AIX in particular, which is pretty hard to do there, but we can actually push that into Elastic or ELK or Splunk or Prometheus. So we're covering the aces. They're all the top 4 time series databases that I've come across anyway. No change here. There's 10 videos out there that you can watch if you want to get up to speed. Right, new content. It's had a bit of fun here. I actually joined a project that had 150 Power 9 servers in a cluster running a 5-day soak test. So this was running the machines at 100% CPU busy. I said 100% is really hard. Let's go for 99.9 because we need a little bit of CPU power here to make sure that the tools run and we can still log in. And they also wanted to hammer memory because they had quite a lot of memory in each of the servers, and it's 1/4 terabyte. So 150, that's 500 terabytes, 70 terabytes. No. 37 terabytes of memory now. That adds up and generates heat as well. So they wanted that busy. They wanted to run it for 2 days flat out. They wanted a quiet day to let it cool down, and then another 2 days flat out. And I said in the blind in here because we weren't allowed to run a soak test before we started the soak test. So this was just put it in, install it, get the network running, get the tools running across the network and things, and then start the test. So this is a really sort of straight out the door. This is what was delivered. And fortunately, we went straight through and did no problems at all. There was one little error flashed up. It was saying it wasn't sure about one of the LED boards in the front of the server. But it stayed up and running anyway, so the customer was quite happy with that. The problem is they had an Intel-based system that we're replacing, and each of the nodes were crashing all the time, and they really wanted to get out of that. It's a major pain point. In Formula One racing, there is a limited capacity to do modeling on computers. And so if the model crashed, not the model cars, the actual aerodynamic modeling system failed because nodes are falling out left, right, and center on these big runs, then that's just wasted time, and they can't redo the modeling in the fixed amount of time they have to do that. That is limited so that we don't have one racing team having the biggest computer on the planet and getting their aerodynamics better because they have more money to spend on computers. But anyway, we went through that and it was fine. We had all the nodes wired up into njmon, and in the computer center there, they had a great big 30 feet across screen, and so we had all the graphs up in there. I found out that on a graph, if you have more than about 32 lines in a graph, it gets so messy you can't see what's going on. So we had, I think it was 6 altogether, sets of graphs up on a great big screen so that everybody in the computer room could see what's going on. If it had gone wrong, everybody would have known about it. I'm telling you this because there's a video out there, the URL's at the top. It's 2.5 minutes, and I'm front of camera, which is really, really hard work. And so you can see me talking. I thought it quite funny or quite terrible on how I feel that day. But there you are. You can have a look at that if you like. I'm not allowed to tell you which Formula 1 racing car team it was. They said, well, you can do. You'd have to sponsor us, and it would only cost several $1 million, euro, dollar, pounds, to do this sponsoring, and IBM said, we're not putting that much money down to get a good reference name, but it was one of the ones you see on the TV all the time. Okay, now, recently, this month, so this is completely new, a lot of it's only like a week and a half old, 2 quite good ideas. I thought I can fix that one in a relatively short amount of time, so I just went ahead. If you want to look at the graphs, there's some obvious measures, isn't there? The utilization of the CPU, the I/O rates on your disks and networks, that sort of stuff. But we collect a lot of statistics, but it's difficult sometimes to find them. And if you don't know they're there, you don't know that you can draw a graph. And documentation's not easy, is it? It's so boring. The other one was that if you want to add some extra stats to the nmon collection, then that's another tricky operation, and we've got a solution for that. So it's difficult to write documentation. As I said, it's so boring. JSON format is a little bit self-documenting-ish. We can, you get some of the names in there, can give you a big clue. If you're not familiar with the terminology, it can be quite difficult to work out what they mean. On AIX, the names of the stats are exactly the name of the data structure, and the values inside the C stat structure. The names are one-to-one, so you could look in the perfstat library header file to find out a little bit more information about what's in there. But I did that because that's another way of getting documentation about the stats. And I thought, well, hang about, I'm not the only person suffering with this. If you look at statd, which is a standard stats collection package for Linux, I couldn't find anywhere where they've listed the stats. And I wanted to do a sort of compare with the competition. I don't know how many stats there are. I still don't know. I think you have to go and install it all, switch it all on, write a bunch of scripts to say which features you want on, then you collect all the stats, then you look in the InfluxDB to find out what you got. It seems a peculiar way of doing things. So I wrote a shell script that pulls this information out of the nmon data, the njmon data or nmon data. nmon, of course, lists it in line protocol format, and that's a lot easier to deal with JSON. If I was looking at the JSON, I could have written a Python script that looks at the JSON format and outputs, but shell script's good enough. Most systems administrators or performance people can hack into a shell script. It's all of like 5, maybe 10 lines long, so I don't think it's a big deal. In InfluxDB and similar things in the other time series databases, we have what's known as a measure. So these are groups of related stats for computers, blatantly obvious what we're talking about: CPUs, memory, disks, and networks. And then inside each of measure, there's a lot of individual stats. So we got user system idle weight. For disks and networks, we got read and write kilobytes a second, packets per second, and those sorts of things in there. And then we got the kernel stats with run queues and all sorts of other things going on, and file systems and paging and all that sort of stuff. But you get the idea, I hope. Now, some of these things, though, there's variable number of resources. There's variable numbers of CPU. You can have one CPU, or you could have 100. Disks, typically on a small virtual machine on Linux, you tend to have one SDA. Peculiar name, but there we go. And one network. We have AIX running with 4,000 disks. And so you have to have a way of dealing with those. And this is a term that I made up, is submeasures. So you have CPU, like totals, and you get user system idle wait. And then you get CPU with an S on the end. And then there'll be a submeasure for CPU 0, CPU 1, CPU 2, all the way up to how many have you got. And each of those would have a user system idle wait, similar with disks and networks. And they're sort of variable number resources. Different virtual machines will have different numbers of these resources. And with Power, we can dynamically change the number of CPUs, add or remove disks, add or remove networks. And with JSON and the line protocol, we can handle that now. We could not handle that with nmon in the past, but that's what we've got in measures, stats, and bear in mind these submeasures as well. So I ran my script, and wow, I didn't think it was that high. I keep adding them because you don't really notice. So I've got a small AIX virtual machine to cause, I think it had 4 disks, 1 network, and so we're kind of running at 1,400 statistics in there, 22 measures, and a whole bunch more for those resources that have multiples of them. Then for Linux, of course, different source code gathering the data, all a bit of a mess, I'm afraid. A lot of out of /proc, and every single file has its own format, but we're up to 800 stats out of Linux. And I think, it's only impression I got, I'd love somebody to tell me, that statd is down at like 100, and we're up at 800, so we're gathering some extra stats. We're adding some value on what's the standard thing in the Linux world. Okay, so this is like the output over here on the left. So we run this nmon. You run it nmon with like, give me 1 stat after 1 second and put it in a file options, minus S, minus C, and minus F. And so you've got a file in here. You can have a regular one with hundreds of snapshots if you want. It should survive. So it's telling you where you got the data. Then we have the measures. If you look down here, measure config. Now, config is largely strings in here, names and feature numbers and all those sorts of things are down in here. CPUs, you can see that they're floating point numbers in here. And have I got one? I haven't got an example of them. If it has an I at the end, it means it's an integer. Now, the first time that InfluxDB sees this thing, it will note the integer, and then if you try and supply a floating point, it will just say no. To completely ignore your attempt to load this data. Strings, of course, are in double quotes, as you can see here. Oh, this one wrapped around. I think I fixed that now. Right. There's also these things in here called tags. So we have the host name, what operating system it is, what the architecture of the CPU is, serial number, and this is an IBMism, the MTM, the machine type model. So this is the type of machine, which is Power 9 scale out, and this is the particular model of the machine. So these are in the data as well as the measures and the stats. These are used to look things up. So typically you want to draw a graph, you draw a graph of a particular host. Now, rather than hard coding in all the graphs the name of the computer, my host name is known as Blue. It can look at all the hosts in here and all the variations that you can see in there, and we can get Grafana to give you a list of the hosts, and then you can select which host you want, and then it draws you a graph for that host. Then you can change a different host and look at their data and perhaps compare and contrast it. So these are quite important, and maybe it's a bit of overkill. Serial number can be used so that you can find all the virtual machines on one machine. Or the MTM can be used. Just look at all your scale-out servers, or all your enterprise E980s and things. This is so that you could, in theory, just find your Intel machines or your Power machines, as an example in here. In the OS, of course, the statistics are different for AIX and Linux, and so it's OS equals AIX. You can specify when you're trying to get a list of virtual machines, so you get the AIX ones, or you can say not AIX, and that picks up all the Linuxes, the Red Hat Enterprise, the SUSE Enterprise, and Ubuntu as examples. Okay, So this allows you get, well, roughly 1,450 lines. There's a few extra lines in here as well. And you can see all the stats. You can search in the output file to for particular things. You know, it's called a run queue, but how do we actually spell that? It's got an underscore in the middle, for example. And you can go and find that, and then you can find the measure it's in. So when you get to Grafana, you can immediately draw the graph. Well, here's an example of the number of CPUs. Well, it's going to be an integer. You can't have half a CPU. You can on entitlement, but not on the actual numbers of them that are being scheduled. To be honest, the integers are a bit of a pain in the neck. InfluxDB does very well. Just stick them all in as floats, and you never get this problem. I made a mistake early on that I thought something was an integer, but when you're doing it over time, so you divide it by 3 seconds, and you end up with a fraction, and then it doesn't work properly. It does very well. If you made this a floating point, it will know when it's drawing the graph not to put 16.000000001. It will round that out, and so it does the right thing with integers anyway. Up to you, of course. We've got at the moment nmon and njmon. We're doing numbers, floating point numbers to 3 decimal places. You might want more, you might want less. I get some people trying to measure things within nanoseconds, and you're thinking, hang about the function is going to take longer to run than that. Just trying to capture the data. Right, so that's the nmon list stats. There's an article here on IBM, and that gives you the tags, measures, and statistics. Let me know what you think. If you don't like it, let me know. I'll see if we can fix it up. I'm sure with some strange data, it will not work with commas and things inside strings can get a bit tricky. Right, now this is all very well. We've got our data collectors, InfluxDB, Grafana, graphing it on your screen. But what happens when I want to add my own stats? And maybe you want to monitor your application. Oracle, for example. You want to measure how many transactions per second it's doing, how many rollbacks it's had because the transaction failed or the user logged out halfway through, or hit ratios into databases, or whatever it is you want to run. And I've had some people want some really weird numbers. One was a very big bank in Germany, but not Deutsche Bank, that they like to have a very limited number of set configurations for the AIX, the 7.2, TL4, Service Pack 2, but they don't want Service Pack 3 and Service Pack 1 around. You're only allowed to run on certain ones that helps with their testing. So they actually hashed those things all together into one gripping number, and they wanted that added to the database, and they could go and find the virtual machines that weren't at a standard version control level. It included fixes as well, for example. Well, I can't say everybody would want to do that, and they wouldn't have the same hashing algorithm to do that. So how can we actually add that? Now, we had a special feature where you can put code inside the njmon and nmon to gather the stats that you want, and it will be included with all this. But that was, you have to be a C programmer and you have to get it right, and people were reluctant to do that. So we wanted some other easier way to do it. Now, with njmon, we're using JSON format, of course. That can actually introduce a problem because it's very easy to get JSON data slightly wrong. And if you then present slightly wrong influx data to InfluxDB, it just rejects the whole lot. It says, that's not badly formed JSON, and won't accept the data. Now, you might think you got 2 lines here, the 2 sets of JSON, but they're not quite the same. And can you spot the bug? Of course, if we're in a bit of a room in here, I could actually see you. I can't at the moment, as I'm in full screen. But let's just move on. There's 4 bugs in this piece on the right in red. There's a missing colon. This is 2 single quotes instead of a double quote. This is a dot instead of a comma to separate the fields. And this is always a pain in the neck, this one, that you have the last thing in here. You're not allowed to have a comma at the end, which means you have to, if this njmon is generating this stuff, it has to try and save the data, but if it turns out to be the last one in a structure, it has to get rid of this comma that right at the end. The way I do it now is that it all goes into a buffer, and if I hit the function that says that's the end, I look in the buffer and delete the comma to get them right. A real pain in the neck. So I don't want users to give me JSON data because there's probably a 50% chance they'll get it wrong. I'm sorry. I've had so many mistakes myself. I don't want to go there, and then I don't want to debugging your JSON. A nice way to prove if it's JSON or not is actually to load it into a Python dictionary. That will tell you pretty quickly that it's not right and what's wrong with it. Okay. So if we then move to nmon, we have the influx line protocol data, which is a lot more safe. So we have something called the measure in here. This is all the same data, right? And then you have user, system, idle, and await with floating point numbers with commas separating them. Not too bad. Most people could get that right. There is alternative, strings, just double quotes has to be around here with a comma if there's more things afterwards. I've already had people with these sorts of problems when you're supplying it to the command that I've written, is they're not aware of the fact that the shell will strip out these double quotes, and so they weren't actually being passed to the command. So a big flashing red lights have to be put up that this isn't right as we're going. Yeah. And they really couldn't see it. I said, you forgot the double quotes. No, I haven't forgot the double quotes. They're there. And he said, no, but if you look, in fact, the command outputs what if it goes wrong, and it gets back something from InfluxDB quite categorically showing you that these double quotes are missing. And he was looking at the input as fine, and the output of the shell was wrong. So eventually you have to escape these things to get that right. But anyway, everybody's going to have to learn that one. Right, so we have a measure called a command, so that you can save this independently of njmon, so you don't have to do it every 30 seconds or whatever. You could do it once an hour. Maybe it's more configuration information that would not change more than once a day, for example. So you could slow it right down and just get it off a cron tab to do it once a day to give you an update of the current state. So you can write a script that collects the data, puts it in this fairly simple format, and then we can pump it into the database. You can then graph it along with all the rest of your data. Now, what a lot of people don't know, I'm familiar with big databases in production servers. That with AIX, I learned this with nmon. If you say, I want to add some software to a production server, you just get... The system administrator looks like you are mad. What planet are you from? That ain't going to happen. And over my dead body is the reactions you get. Now with InfluxDB, you can use the curl command. The trouble is, curl command is not standard with AIX. Definitely with Linux, depends on the version. Of course, if you install curl, it's probably, I haven't looked, but it's probably got prerequisite of other packages, or maybe 15 of them if you haven't got much open source installed. So then you get into security issues, and the customers go down to perhaps, even if it's open source, getting somebody to read the code to make sure there's not some Trojan horse in there. You'll have to go into some pre-production testing for at least a couple of months, and they'll try and prove that it's going to make mistakes, or it's running commands under the cover, or it's not trying to send packages over the internet back to the writer or something. And if it passes the pre-production test, it's going to take 2 years to actually roll it out across the estate. But they don't upgrade production servers just because of one little command, like a data collector performance stats. It may take 2 or 3 years before you actually find it on most servers. But if it's one little command, completely independent, the source code is only 200 lines, and you can see exactly what it does, then we can get away with it. That can go into user local bin, for example, and then you can start calling that in a function to get your data added. So here's some examples. Now, measure is actually, I took nmon and deleted 90% of it, got it right down to the bare bones, because it doesn't need to collect any data now. You're handing it the data. So this measure command, I got a blue star in here. You have to give it the Influx host name to actually send the data to, and the Influx database name that you want it added to. And then we have, this is the measure, and then these are the statistics as we looked at before. Of course, the measure has to be something that njmon or nmon is not already using. If you put in CPU here, or CPU under totals or something, then it will say this data is invalid. None of these names match, if you're lucky. But I'll give you some examples. Databases, perhaps you want to know, how transactions and rollbacks and hit ratios on the SGA. For sales, you might want how many items have been sold, the average cost, how much profit you're making so far today. For user sorts of things, you could say how many users are online. We actually measure that using the uptime command. But most people don't allow anybody to log onto their big servers these days, but this might be the online users to the database or website or something. How long their sessions are in minutes, for example, how many clicks per minute they're doing. So it's coming out of Apache web server rather than the operating system. Or you could actually say do things for measuring IT tasks. So here we've got how long the data load took as part of the batch run last night, how long the backup took to run and finish, and how many minutes it took to run the batch processing, for example. Then on a day-by-day basis, you can find some trends of is this getting longer or taking more time of your busy day, and is the batch going to run into the startup as your users logging in at 9 o'clock in the morning, as an example. Once you have a time series database available to you, there's no going back. You just find more and more stats that you can think, oh, that'd be good. We could track that. We could get it to draw graphs. Compare that to how busy the CPUs are, or did the disks peak when we switched that feature on? That sort of thing. All sorts of things can start being measured. Right, something completely different. This guy here called S-Rant. This is the name of his website anyway. So published by Weird. Okay, so he was the guy that looked at the AIX metrics and trying to put them into njmon, and one of his ways of trying to do that was using Telegraf. And so, wow, he sort of gave me the clues I needed and the encouragement, if you like, to actually get this working with njmon and nmon. In actual fact, it's the nmon process that's producing the InfluxDB line protocol, and our daemons push that into, well, this is normally InfluxDB. Telegraf come from the same team, the same company, InfluxData, as InfluxDB. So Telegraf can pretend to be InfluxDB. Now this is one of these sort of universal transportation talking things. So they tend to use this for two different real reasons. One is you can push your data into Telegraf, it can receive that data and then push that out to multiple Influx databases at the back end and let you do an HA clustering of your data across two machines, maybe in Europe and America, in case something goes wrong. Another thing they can do is there's dozens and dozens of input functions or plugins in here for all sorts of data format, including sort of logging and all sorts of things. And then it'll take that data on board, and then you can have an output plugin that goes to where you want. So in this case, I wanted Prometheus. Now Prometheus won't accept a push from the other end. It pulls the data when it's ready. So Telegraf's actually doing this, capturing the data, holding the data until Prometheus wants it, and then forwarding it on. And this is the sum total of the configuration you have to do to get this to work in a Telegraf. And I was like amazed that allowed me to work around a push-pull problem, and it accepted my InfluxDB data first time, Normally when we connect to Influx database, we have to log in and select a database. Well, Telegraf doesn't need to do that, so we put in a little -w option that said don't tell him about the database and the thing. He's already knows what to do with the data, and so it just pushes it straight through to Prometheus. There's a graphing engine from Prometheus. I managed to work through that. Pretty crude, but it's workable. You can see the data in there. Usually people are pulling the data out with an API, REST API type functions. But you can also use Grafana to look at Prometheus, and there it was. It all looks much like it would do as if it was on InfluxDB. So that's how that worked. And I've written up an article on that for you to go and have a look at. This is a support page. This was, if you've been around a while, Developer Works. This is one of the places that Developer Works stuff went to. Okay, so I don't know how many charts I've got here. Yep, got 10 more. So let's go through these quickly. Right, Grafana. Wow. Every time they release this, it's like having new toys, new graphs to actually go on. And they got a web page for examples. If you go to the Grafana web page, and the buttons along the right-hand side, it goes in there. It says, what's new in this next release? And you can see the new graphs that they're supporting. I've actually written these next couple of slides for a session I'm presenting with Grafana and InfluxDB. So up in here, you can actually put logos on the dashboard if you want. There's no documentation on that, but somebody did it and wrote it out, so I copied that. Here we got a donut chart, which is really a pie chart, but donuts are just nice, aren't they? So that's good. This background came out maybe a year or two ago now, and that really helps if you're trying to sleep in front of your screen. If it's all white, it's very, very bright and it's difficult to get off to sleep. That's meant to be a joke, but we have rumors about our operators. This one up in here, number 4, is when I was a lad, everybody would like these graphics equalizers on the front of your stereo to show how much bass and treble your speakers are outputting. But here we go. We've got a similar sort of thing. These are file systems being monitored here. Number 5, I call these button single stack graph. So this is the single stat, how much CPUs you're using, consumed, but it also draws a little graph. So you can see things, oh, this is a downward trend, that's okay. And if it's got an upward trend, if it goes over a threshold, then instead of white, this will go orange or red or any color you want, actually, or any threshold you want. So you can actually put a lot of these buttons on a screen. I could probably get 20 by 10 on my 27-inch screen in here. So there's 200 stats I could be monitoring in one glance. And the ones that have gone orange or red, they're the ones I need to, they will draw my attention and I'll go and fix that. So that's very high density information. There's a better one of these, but I call these the Blue Ridge Mountain Range. There's one that goes up and down, but you can color things. And they just look like a mountain range. It just makes you feel comfortable and relaxed while you're looking at the graphs. So maybe it's me. And there's a thing called a carpet graph. I'll come to that in a minute. Now, I'm assuming that, I hope nobody knows what the Dolly Parton curve is. I found out in a recent conference call that nobody knew who Dolly Parton was. If you're a youngster, they all had to go and find out what Dolly Parton meant. So this is the Dolly Parton curve, very famous thing in the computer world. This is time along the bottom and how busy the CPUs or the computer is. Yeah, so everybody, this is like 8 o'clock in the morning, and by 9 o'clock, everybody's logged in. There's a morning peak. The rush hours, typically, a lot of people don't take rush hours, or it's staggered over 2 or 3 hours. Of course, some people are taking 3-hour lunch breaks. And then there's a peak in the afternoon when everybody tries to get what they're meant to do done now. And then people start sliding out at 4 o'clock, and by 6 p.m. it's all done. And I like this black-white graph because now we're in the night. There's a whole bunch of quiet time. Then a batch runs. Well, batch tends to run, if it's written well and multi-threaded, then it runs at near 100%. There may be different phases of it running at different busynesses. But the batch run typically 100%. So if you say, what's the busiest time of the day? You nearly always get 98% or something. If you looked at this sort of graph, looking for 95 percentiles or something, you'll catch a batch where you actually really care about these two, because it's when the users are online, they're the people that will complain if it's slow. So these are the points of interest, and this highlights the Dolly Parton curve a little bit, perhaps. There's a peak in the morning, there's a peak in the afternoon, and it's how long the batch run takes. This, as the data volume goes up, or the data take-on goes up, when you're pulling data into your database or writing out massive reports or sending the data somewhere else, then this is going to creep later and later in the day. At some point, of course, it will creep into the 8 o'clock morning here, and then you're into a real mess if you can't finish your batch run while people are trying to log in. You could be having major problems. Now, this doesn't really work if you're a website running internationally, although you'll still get a surge of people arriving at your website, perhaps the Europeans coming in, phased over 3 time periods. The same thing with America, or the Americas now. The people in South America are doing a lot of compute these days. So you have different sorts of peaks and things, and maybe you're not running batch on a web server. So if you take an average of this day, you'll come out 50%. And I've seen a lot of gotta be careful what I say. A lot of performance tools will just say, "Yeah, nothing openable at all." And while this creeps right up to 99%, knowing full well the following day you're gonna hit a crunch point, and then you get people complaining. It's also periodic over a day. It's also periodic over a week. Typically, you'll have Fridays are busy. This Friday afternoon peak, everybody's trying to get the work finished to go for the weekend and not work late to get it done. Also, there's end of month processing, may give you a couple of busy days there. Then there's end of year or end of financial year, or a retail year at Christmas times and things. Will have different set of peaks on, not typical of your every week. And then we got these batch overtimes we're trying to monitor. So there's a whole bunch of problems that this graph is highlighting that we want to get out of our performance data. So here's the doesn't actually say at the top, looks on the next slide. This is the carpet graph. So we have days of the week. I've actually got 3 weeks up in here. There's a half a week at been in and half a week up in here. So it's like a 4.5 week view. And I looked at this data and I thought, well, it's slightly busier during the day, but this isn't a production server. So this morning I thought this data is really boring, so I started putting things into cron tabs to generate workload, and you can see, oh, it started this afternoon, and then we had these busy periods. I tried to make it look reasonably accurate. 8 o'clock to 10 o'clock, there's a busy periods in here. On this Thursday was the busiest one, and this day in here is a little bit busier as well at 2 p.m. And you should expect a batch run probably up here in the very early hour of the morning as well. Okay, let's move on. All right, here's the busy bits. These are the bits we care about. These are the bits which are going to have a crunch point first. So we want to start looking at those. I could have faked up some batch run that's 1 hour, then start going 2 hours, and then start going 3 hours, and eventually you find the green bits disappear, and then we're into the other crunch point. So how to work out how to do this graph, that's now on my to-do list. If you've got any ideas, please do let me know. One way is on the InfluxDB, we could write flux commands or programs that extract the data, take out the things we don't want, and then push it back into the time series database. Or we could be doing things with time series of particular, Fridays at 8 p.m. with our graphs. I'm not sure which way would be the best way to do that. So I'm trying to think what would be what graph am I looking for out in the output? Well, this is what I call removing the weeds. If you delete all the times you don't really care about, so this is the the 8 to 10 bit, then you can get these sort of peaks in here, and your eye is pretty good at saying, yeah, flatten up a bit there, and it's starting to rise again, and we're going to hit a crunch in like 2 or 3, maybe 1 or 2 Fridays further on. We're going to hit 100% during that peak period of the week. Another way is just having drawing graphs 8 to 10 for the different weeks, maybe different colors. I was thinking of the Blue Ridge Mountains, darker ones being more recent. And this is the graphs for those 2 hours. These graphs stretched out a bit, and you can get the impression, well, we've only got another 1 or 2 weeks to survive in here. Or maybe this is a better way of doing it. We can see these two leveled off a little bit, but now they're accelerating up. So this is the last Friday. I've added up accumulated CPU minutes in here, so you can see them growing. Once they get to all the minutes of those 2 hours of busy, then we're going to hit the crunch point. So this will allow you to do an extrapolation fairly easily. So that's the sort of thing we're working on running with the big production workloads. Right, this is a reminder to me. Next time, I want to make a video of this. This is the quick win, how to get the Influx and Grafana installed very quickly, create the database, start up nmon for a couple of hours, and pull down a dashboard and see a graph. You'd be a 10-minute video with a gap in it while we collect enough stats to start drawing a graph. So hopefully we'll have that sorted out next time. And that's it for this meeting. Thank you very much. And come back 7th of September. I will tweet and LinkedIn. And thank you very much for your time. Are there any questions?
Nothing in the chat, Nigel.